Okay, Bismillahirrahmanirrahim. Welcome to this lecture on data analysis. Today we will be talking about coefficient of variance. So these are the different coefficient of variance are skewness, measure of skewness, kurtosis, types of kurtosis, and difference between dispersion and skewness. So we will discuss these topics in our today's lecture. Okay, so now what is coefficient of variation? The coefficient of variation, 1 minute. Okay, so the coefficient of variation is a statistical measure of the dispersion of data points in a data series around the mean. Okay, we have already discussed what is mean. So the coefficient of variation is actually measurement of the dispersion of data point, dispersion or spread of the data points around the mean. The coefficient of variation represent the ratio of the standard deviation to the mean. Okay, so it is a ratio of the standard deviation with the mean. So these are two concepts. One is standard deviation and one is mean. So the coefficient of variance is the ratio between these two measures, and it is a useful statistics for comparing the degree of variation from one data series to another, even if the means are drastically different from one another. Okay, so this is actually used for comparison. Now coefficient of variance is, as we have said, that this is the ratio between the uh, um, standard deviation and mean. Okay, so sigma is standard deviation and mu is mean. Sigma is standard deviation and mu is mean, and CV is our coefficient of variance is the ratio or standard deviation divided by mean. Okay, so now these are different data points. Find coefficient of variation for the following point. So here these are the different points. So here you have first to find the mean and then standard deviation, and from these two calculations you can compute the coefficient of variation. So you can do this as homework. Okay, now moments. Okay, so what is moment? The shape of any distribution can be described by its various moments. The first four are, now these are the different moments. The mean, which indicate the central tendency of a distribution. The second moment is the variance, which indicates the width or deviation. It indicates the width or deviation. Okay, so let's say we have points here, and let's say this is the mean and the values are spread around the mean. So let's say we have this structure. So the value, this is the mean, and this shows the spread. Okay, so uh, the uh, the variance shows the width or deviation. So the width means, now we can have mean here, and all the values may have the range from this to this, or it can have also, let's say, this range, or it can have like this range. So this shows the moment. The width or the distribution shows the moment. Okay, now the third moment is the skewness, which indicates any asymmetric leaning to either left or right. So this is spread and skewness. We are interested about the symmetry of the spread. So in coming slides, you will understand how this asymmetry means. Okay, the fourth moment is the kurtosis, which indicate the degree of central peakness or equivalency, the fatness of the outer tail, like how tall it is, and this tallness means that like how the frequency the frequency of values around a certain point. So this is called kurtosis. And next slide, few slides, we will discuss these in detail. Okay, now what is mean? So it is already clear. We have discussed this in previous slides, that it is arithmetic mean. And variance. So variance is defined as the sum of the square distance of each term in the distribution from the mean. Mu is mean, divided by the number of term in the distribution. This is n is the number of samples. You take the sum of the squares of the terms in the distribution and divide by the number of terms in the distribution. Okay, now this is mean, this is sample. Okay, from I up to n. This summation should be like I is equal to 1 to n actually. So xi, where I start from 1 up to n, and these are the number of samples. So for each sample you compute this value like sample minus average value, and you do this for each value. You square that value, then you take summation of all these values, and then you divide this by number of samples. Okay, so this gives you the variance. Okay, sample variance is xi is the value of one observation, x bar is the mean of the value, n is the number of observations. Okay, so this is variance. Now skewness. So skewness tells us the amount and direction of skew. The amount and direction of skew. And what is skew? Skew departure from the horizontal symmetry. So skewness is mean bending, or now this is let's say we have this central value, and on this side we have this shape of spread, but on the right side this is not that much flat, it is stiff, while here on the left it is it is somehow flat, and on the right it is stiff. So this is skewness, like how stiff it is or how flat it is. If the bulk of the data is at the left and the right tail is longer, we say that the distribution is skewed right or positively skewed. Now what is skewed right or positively skewed means? If the bulk of the data is at the left, let's say in this case, so this position is the center, and most of the data are in the towards the left. Okay, so this is left skewed. And here in this case, let's say this is the center, so most of the data is at the right side. And here we say that this is skewed right or positively skewed. Okay, if the peak is towards the right and the left tail is longer, we say that the distribution is skewed left or negatively skewed. So this is left skew and this is right skew. Look at the two graphs below. They both have mu is equal to 0.3 and sigma is the, but their shape are different. So in both these cases, the mu and the sigma is same. So in this case, the standard deviation will be same, but the distribution of data in reality is not same. So the other moment that we use to know or to understand the distribution of data is skewness, which tells us about the right the bending of distribution toward right or the bending of distribution toward left. Okay, so this the skewness shows us this phenomena. Okay, now how skew is computed? So 1 over n and summation I start from 1 up to n and xi minus x bar raised to the power q. So this is again, this is sample, this is the mu or average value or mean value of the sample, and you do this for each sample. You take the cube and then you sum all the values, and then you divide this by n overall divided by n. So mathematically it's not that difficult, although the formula looks difficult, but it's not that difficult, and the computation can easily be done. Okay. Okay, now skewness. So graph the distribution of the following data points. Okay, these are the points, and here you should first take graph of these points, and then you should calculate the skewness of these points using the formula presented in the previous slide. Okay, now kurtosis. So what is kurtosis? The sharpness of the peak of a frequency distribution curve, the sharpness of the peak, that how sharp the peak is. Kurtosis tells you how tall and sharp the central peak is relative to the standard bell curve. Kurtosis is a statistical measure used to describe the degree to which score cluster in the tails of the peak of a frequency distribution. The peak is the tallest part of the distribution, and the tails are the ends of the distribution. Okay, now types of kurtosis. Mesocortic, distribution that are moderate and breadth and curve with a medium peak height. If there is medium peak height, then such type of distribution is called mesocortic. Okay, now this is mesocortic kurtosis. Leptocortic, more values in the distribution tails and more values close to the mean. Okay, more values in the distribution tail and more values close to the mean, that is sharply peaked with heavy tails. Now this is leptocortic curve, and here this value mean that we have most of the values in the peak. Okay, now peak is, let's say, like from here to here, this is peak, and then here and here this is tail, and this is tail. Okay, so now in this case, more values in the distribution tail as well as more values in the mean. Okay, so we have more values at the tail and more values in the mean, but there are few values between the tail and the peak. But now when we look at the platycortic curve, okay, so here the values are equally distributed. What platycortic means? Fewer values in the tail and fewer values close to the mean, that is the curve has a flat peak and has more dispersed score with the lighter tails. The tail is not high, and the values are distributed among the different point, like there is no sharpness, like in this distribution. The distribution for different values is same. Okay, not same, but close to each other. Okay, so this is the platycortic kurtosis, and here the values are equally distributed. But when we look at the leptocortic curve, so here most of the values are either from mean value or close to mean value and close to tail, but at the center location there are few values. Okay, no, this one at these locations. In these locations we have few values. Okay, now this is the kurtosis formula, and xi minus x bar divided by n for all values divided by s raised to the power 4, and s is the standard deviation. Okay, so using this equation we can find the values for kurtosis. Okay, now the description of kurtosis is as follows. Based on the value of kurtosis, the distribution can be classified into three categories. The distribution with kurtosis equal to 3 is known as mesocortic. A random variable which follows normal distribution has kurtosis 3. If the kurtosis is less than 3, the distribution is called platycortic. Okay, so for platycortic, the distribution should be less than 3. Okay. And if the kurtosis is less than 3, the distribution is called platycortic. Here the distribution has shorter and thinner tails than normal. Okay. If the kurtosis is greater than 3, the distribution is called leptocortic. Here the distribution has longer and fatter tails than normal distribution. Okay, so these values can be obtained from this equation, and based on this value we can say whether this is mesocortic, leptocortic, or platycortic. Okay, now the difference between the distribution and skewness. Okay, so what is the difference? It measures the tendency of a data set distributed over a range in statistical analysis. It measures the tendency of data distribution. Now what skewness does? It measure the symmetry in a statistical distribution from the normal distribution. So here we are interested to know about the symmetry, and here we are interested to know about the distribution. It deals with the distribution of values of a set of data around a central point. It studies whether the distribution of values is symmetric or asymmetric. Okay, now in dispersion, range, standard deviation, and average deviation are the most basic yet common ways to calculate dispersion. It is calculated in the form of positive and negative skewness. Mean, median, and mode are the common ways to calculate skewness. Okay. Now, it determines the degree of variation in the set of data. It determines the extent of variation. The degree of variation and the extent of variation in terms of lower and higher values. It is used for other statistical methods such as regression analysis. It can be used for economical analysis and financial and investing. Okay, thank you very much.